This isn't like changing a socket at home. This is medium voltage, and here mistakes are paid for with explosions. Watch the beginning. The cut on the outer jacket looks rough with the reciprocating saw, but it isn't. It's a calculated cut. The technician is removing the metallic armor, and that black layer underneath isn't just plastic. It's the semiconductive screen. Critical fact: if you damage the main insulation right below it, this entire job worth thousands of dollars becomes useless. Now look at how he removes the metallic tape. That's the electrostatic shield, whose purpose is to confine the electric field inside the cable. This is where the fine surgery begins. He separates the three phases, measures twice before cutting, and doesn't use generic tools. Every layer of the cable requires a specific tool to avoid deforming it. By cutting each phase to the exact length, he ensures they enter the switchgear bars without mechanical stress. Here, the geometry of the cable is as important as the electricity itself. Now we enter the sterile zone. He's stripping the XLPE insulation to expose the conductor. Pay attention. What he applies now are stress-controlled tapes and mastic at the base. Why? Because once you cut the shield, the electric field becomes chaotic. If that transition isn't smoothed, the field will eventually puncture the insulation. Also notice the grounding system. He uses a constant force spring to secure the grounding braid to the shield. No welding that could overheat or damage the insulation. This is pure engineering. And now the most satisfying part? Cold shrink technology. He installs the trifurcation boot, and when he removes the plastic core, the silicone material contracts without needing heat. Its expanded form returns to its original shape, gripping the cable with permanent hydrophobic pressure, sealing out moisture and dust for decades. Now comes the power connection. He installs copper tubular lugs and uses a hydraulic crimping tool that generates several tons of pressure. The crimp must be perfectly hexagonal. If air pockets remain, resistance builds up, creating hotspots, failures, and fire. Finally, he installs the insulating termination bodies. Those skirts you see are not for aesthetics. They increase the creepage distance and prevent electrical arcs from jumping to ground. Look at the final finish. Mastic seals at the top, phase identification tape, and a flawless connection to the bus bars. A clean, precise, and safe installation, ready to operate reliably for the next 30 years.